Hello and welcome to Lesson 85, using cross products to figure out whether or not two fractions are equal. You notice here on the board I have two fractions. I have 3/5 and 4/7. So far we've learned to tell if these two fractions are equivalent, we have to have something called a common denominator. And in this case the common denominator would be 35, make for a fairly large number. I'm going to show you a different way to do this. We're going to use something called cross products. What I want you to do is I want you to watch carefully. I'm going to take the 3 and the 7 and I'm going to multiply them. So 3 times 7 is equal to 21. 4 times 5 is equal to 20. Are those the same number? And the answer, of course, obviously is no. Since they are not the same number, then 3/5 and 4/7 are not equivalent fractions. You would want them to equal the same number in order for that to work. Let's try a little bit different version, shall we? I'm following along in Lesson 85. If you want to follow along on page 441, 442. 442 at the bottom, we have 8 over 12 and 12 over 18. Okay? 8 over 12 and 12 over 18. So we do our cross products here. And 12 times 12, we take this one and these two and multiply them, and these two and multiply. So 12 times 12 is 144. 8 times 18 is 144. So are these two fractions equivalent? Yes, they are. So that works out very, very well in our case. The other thing we can do with this particular method is if we have an unknown number in a fraction, and that example is on page 443, we have 6 over 9 is equal to 10 over m. Now in the past, what we've done is we say, okay, how many 6's are in 10? Well, in this case, 6 doesn't go into 10 evenly. What we do say is we have 6 times m should be equal to 9 times 10. So let's put this into an algebraic equation. 6m is equal to 90. Divide each side by 6. That crosses out, so we have m is equal to, how many 6's are in 90? We have 1, so that leaves us with 30, and so we have 15, so m in this case is equal to 15. So that's how we can use cross products to find an unknown number. Let's take a look at just a couple of the examples in our books, bottom of page 443. Letter A. We have, letter A, 6, 9, 7, and 11. Is 6 over 9 equivalent to 7 over 11? What's 6 times 11? 66. Does it equal 7 times 9, which is 63? The answer is no. That does not work. This works in every single occasion. Sometimes it's easier to use cross products to find out an answer as opposed to finding out fractions that would work to make them together. So for your assignment for tomorrow, Lesson 85, I'm going to have you do questions 1 through 25. There is an early finishers question on page 446. It's a 2-point early finisher, so if you want, go ahead and work on that. Page 444, questions 1 through 25. Have a good day.